So when we looked at the graph, we really saw how we can't plug in negative numbers into our function, or how our domain's limited into being 0 or greater. So that's what's coming through with this general form of if we're taking the square root of something, whatever it is underneath that square root, whatever's underneath there, whatever expression or number that's coming through there, that expression has to be more than or equal to 0. And that's what we can use to set our domain. So without graphing the function, we can determine the domain of our radical function by using this property that whatever's underneath, that's restricting the domain, and it's just that whatever's underneath has to be greater than or equal to 0. So let's try this out. There will be one case where we need a graph to help us out, and a little twist in there too. So, alright, this function right here. When I'm looking at this 3 is good, this plus 4 is good, but where my domain's going to be restricted is with that radical. And it's all about what's underneath the radical. So to figure out the domain, what I'm going to do is take what's underneath that radical there, so just the 12 minus 6x, and it's just the result of that calculation has to be more than or equal to 0. Now that I have this relationship, I can solve for x. Finding which values for x makes this work. I'm going to go ahead and add 6x to both sides. So that we'll have 12 more than or equal to 6x. Then I'll divide both sides by 6. So I get 2 is more than or equal to x. So for my domain, x is less than or equal to 2. So we're starting out at negative infinity, going up to 2, and we include 2 in the answer, so we need a square bracket there. Alright, our next one here, same idea. Whatever's underneath the exponent there needs to be more than or equal to 0. Now, we can start solving for the variable. In fact, I could subtract 5 from both sides. But taking the square root of both sides here, well, first of all, it's going to cause an issue because then we're taking the square root of a negative number, and we can't do that. So this is where there's a little trick to it, in that we're going to use the graph to help us out to see what's going on here. And in fact, I can go ahead and graph this situation, meaning I can graph t squared, because that's just our standard parabola. I'm just going to sketch this. So x squared looks something like this. Don't need to worry about being too detailed here. And then I have the line y equals negative 5, which is down here somewhere. And I want to know, where is the quadratic function larger than or equal to negative 5? And the answer is going to be absolutely everywhere. Everywhere our quadratic function has output values that are larger than negative 5. Like we could compare at 0, the output of t squared is 0, and the output for our function is negative 5. Well, 0 is larger than negative 5, so that holds true. And then it would just hold true for absolutely everything, because every y value on that function is bigger. So with this, the domain is absolutely everywhere. So all real numbers, negative infinity to infinity. And if you're unsure, you can always graph it. So the square root of t squared plus 5. So we see something like this, and I can see my domain is all real numbers. So it's by squaring x there that we're allowed to plug in negative numbers, is that no matter what I plug in for x, it's going to turn positive there, and then by adding 5, just makes it even more positive. So with that, I don't need to worry about taking the square root of a negative number. Alright, with this one, I'm taking the cube root, and with the cube root, the domain is all real numbers, so I don't have anything to calculate here. All I'm going to write is domain, negative infinity to positive infinity. And that one's done. Nothing else to show. Alright, this one has a teeny tiny little twist to it. So I see my radical there in that 2t plus 6. And typically I would just grab that and say 2t plus 6 has to be more than or equal to 0. However, I have one little extra piece here, which is that that denominator cannot equal 0. So, really, whatever I get out of this shouldn't be letting that equal 0. So what we can do is solve this in two separate pieces, and then I'll show you how they combine. So I'm going to solve that first piece, and then I'm also going to look at the square root of 2t plus 6 cannot be equal to 0. And actually, I'm going to start with the equation piece, because I'm going to square both sides of the equation, which would give me 2t plus 6, and that cannot equal 0. And then what you can notice with that is these look super similar now. It's just the only difference is the symbol in between, but I have my 2t plus 6, 2t plus 6, 0, 0, and here I'm saying it can be more than or equal to 0, and here I'm saying it cannot equal 0. So how I could combine these into just a single step is pretty simple with this inequality setup. All I would do is take away the equal part and say 2t plus 6 must be strictly larger than 0, because we're saying it cannot equal 0. So you can combine it in that way or solve them separately. I'm going to go ahead and solve them separately and then just show you how they combine at the end, but it would be the same thing of solving just the single inequality. So I'm going to subtract 6 from both sides, divide by 2. I'm saying t has to be more than or equal to negative 3. Over here, subtract 6 from both sides. That's the same solving. And we're saying t cannot equal negative 3. So that's where, if I combine these two together, I'm saying t has to be strictly more than negative 3. It should be more than, and it can't equal it. So the domain is starting at negative 3 but not including it, so I'm going to use parentheses there, and then going off to positive infinity.